So I did take some time to review number 14 and number 16, just because it's been a little while since we factored, and that does play a role in how we would go ahead and you know, work this out with trig identities, right? So back in the day, if you worked with a problem like number 14, you kind of unfoiled it a little bit. So the shortcut I commonly convey, if we're unfoiling or stuffing two sets of parentheses, you first may want to think about, well, what should those first terms be so that you can make x squared? What two things can you multiply together to make x squared? And that's not too bad. Yeah, nice job. It's x times x. X times x will give you x squared. And then you see I put some red lines coming out of that -4. What I'm thinking about right now are numbers that multiply to -4, but then they have to add to give us a +3. So things that multiply to -4 that add to +3. Go ahead, Roman.
1 and -4.
So,
No,
Matt.
no, 1.
Oh.
-1 and 4.
Yeah, you got it. Yeah, 4 and -1. +4 and -1 multiply to give you -4. But then when you add those together, you do get a sum of 3. So we can put the +4 in the first set of parentheses, the -1 in the second. You don't have to worry about solving. I just want you to factor these. I know there's an equal sign, and a lot of you are programmed to solve for x when there's an equal sign, but for these, I just want you to factor them. The last thing I always do is I check my outers and inners to make sure, like, I don't know, I did it right. So -1x and +4x actually does make that 3x. So I know I did the problem correctly. So that's right. Keep in mind you could AC group if you have 3 terms. Like if you don't like, you know, this shortcut, you could definitely use your AC grouping. And speaking of grouping, that's actually the technique we would use when you have 4 terms. So here for number 16, I wanted to show you just, you know, how you factor that. And when you have 4 terms and no GCF, you just split it down the middle. And then you just look at your first 2 terms and you're going to identify a GCF between those 2. So when I look at those, I'm like, oh, well, they have an x squared in common. And then I would ask myself, you know, x squared times what would give me x to the 3rd? So I need another x. Bring down your minus sign, and then x squared times what gives you 3x squared? That'll just be 3. And then I move to the other side of my squiggle, and I get a GCF that side. So I have 4x minus 12. And what I notice they have in common is a 4. So I would pull the 4 out and then ask myself, 4 times what gives me 4x? And that's just x. And then 4 times what gives me -12? That would be -3. And then I'm super pumped because we get this thing called a repeating binomial quantity. In other words, I have an x minus 3 chilling in both of those bigger terms. So I can actually GCF one more time to pull that x minus 3 out. And then what I would have left over is an x squared plus 4. Bless you. Keep in mind, if you FOIL this, you would get this original problem back out. So it does work. Down to, we're going to move down to some of the rational equations. And in general, I picked some weird ones. Like I thought 20 was a little strange. So I'll do a couple of these with you. And then I'll cut you loose to finish it up on your own.
I know how to do the top, but the bottom.
The bottom. That. I'm glad your eyeballs went there. That is where they should go. Nice job. So what Annabelle's noticing is we're going to try to subtract straight across the top. But the pain in the butt initially about this problem is we can't really subtract fractions until the denominators are the same. So the first step is to identify what we call a least common denominator. And after your denominators are in factored form, which they are, you know, k minus 3, I can't factor that, and 3 is prime. After they're in factored form, you find the LCD by, you know, I always said, you know, bring down the factor that is your first denominator. So you just bring down the denominator on the left, and then you compare it with this denominator on the right, and insert any factors you didn't write down yet. The issue that I'll run into is that students won't bring this 3 down because they think they already have a factor of 3. Well, that 3 that I'm highlighting right there with my little wandy thing, here, wait, I'll draw your attention to it. I'll turn it into a lightsaber. Okay, see that 3 right there?
Oh, what the heck?
I know, right?
Look at that.
Magic.
Wow.
Strong with the force I am. Okay, so see this 3 right here? That's not a factor. That's called a term because it's touching a minus sign. So we have to bring down this 3 because, well, I didn't write it down yet. It's a unique factor. So what I'm trying to say is this 3, whoops, wrong tool, needs to come down for the ride because I didn't write it down yet. It's a missing factor in my LCD. The big kids usually don't write that this way. They'll write it as 3 times the quantity of k minus 3. It's a little more common convention for writing that common denominator. Okay, the next step is sort of purely housekeeping. Our job is to tidy up the bottom. So I copy down the original fraction. And then I ask myself, well, what am I missing from this denominator in order for it to be the LCD? And really, I'm only missing the factor of 3. So I'm going to multiply the bottom of this fraction by 3. So now that's the common denominator, the LCD. But what you do to the bottom of a fraction, you also have to do to the top. Yeah, essentially that allows us to get one, like that 3 over 3 right there, that's 1. So I've essentially just multiplied that first fraction by 1. I didn't change its value. 3 over 3 is 1. Multiplying by 1 doesn't do anything. So it just kind of changes the way the denominator looks, which is good because I need the denominators to match. I'll do the same thing on the second fraction. Again, just some housekeeping. I need to get my denominators to match. So I see that this denominator, rather, this 3 here, it's not quite the LCD yet. It's missing the factor of k minus 3, so I'm going to bring down the k minus 3. And then again, what you do to the bottom of a fraction, you got to do to the top. Are there questions on that step? So you just rewrite the problem and you put the missing factors from the LCD in each denominator. Alrighty. I'd love to be able to subtract, it's just right now I don't have any terms. So this is where you have to distribute a little bit. So that new numerator is going to be 6k plus 6 over our LCD of 3 times k minus 3. And then this is a subtraction problem. I'm also going to distribute my 5k in. And again, I'm doing this because I just don't have terms yet. You can't really subtract factors. So 5k times k is 5k squared. 5k times negative 3 is negative 15k. And that is also over my LCD. So check out how cool that is. My denominators match. So finally, I'm ready to take care of this subtraction. And back in the day, to take care of our subtraction, we did a little mnemonic: keep, change, switch. So we're going to keep this first numerator, change my subtraction to addition, and switch all of the signs in the second numerator. And now I can just combine straight across the top. So this is what Annabelle knew a bit about a few moments ago. So 5k squared, or negative 5k squared, doesn't have any friends. But I do see I have a 6k and a 15k. So I can put those together. That'll make 21k plus 6. And then this is all over your LCD. And that's it, you're done. I was going to do one more of these with you to give you some confidence. But let's back it up for a second. Just run through our steps. Step 1, you got to find a common denominator. Step 2, you rewrite your fractions so they have the common denominator in them. Step 3, you simplify your numerators. That means distribute, combine like terms. And then you just perform the indicated operation. In this case, we just added straight across the top. All right. Let me think here for a second. 24, yeah, 24 ended up being one worth looking at. So this will probably be problem number last. I think after this, y'all might want to look at those identities again. I think this one's tricky because that second denominator isn't factored. So let's take care of that. I'm going to go ahead and GCF this one. I'm going to rewrite it as 3n. And then 3n times n would get me the 3n squared. And 3n times 1 would get me that minus 3n. So I'll go to find my LCD by bringing down the factor here on the left. 3 is a factor. It's not a term. It's not touching a plus or minus there on the bottom. So I'll bring down this 3 right here. And then I compare it to the factors in that second denominator. So when I list out the factors of the second denominator, there's a factor of 3, a factor of n, and a factor of n minus 1. So those are all the things that are touching multiplication. That's what defines a factor. So see how I already have a factor of 3? I don't need to write this red 3 down. I have one already. So the missing factors are n and n minus 1. And that's how you find an LCD. So yeah, now we got to rewrite our fractions so that they have this as the denominator. So you copy down your first fraction, that's 4/3. And when I compare this denominator of 3 to my LCD, I notice I'm missing the n and the n minus 1, so I got to bring those down. And then what you do to the bottom of a fraction, you also do to the top. Bring down your minus, and this guy was n minus 4 over, the original denominator there was 3n n minus 1, and I'm like, oh my gosh, that is my LCD right there. So I don't even have to do anything to this numerator because these things already match. That's so nice. So now all I have to do is distribute and perform the indicated operation of subtraction. So I am going to distribute that 4n in, so I got 4n squared minus 4n. And that's over my LCD. And then I would keep, so I kept the first numerator, change subtraction to addition, and switch all of the signs in the second numerator. So that'll allow me to bring the rest of it down. So I have a minus n and a plus 4. I wrote 5. That's a little thing we call hand-brain disconnect. All right. Yeah, and then you just combine like terms right across the top. So I got 4n squared minus 5n plus 4. And that doesn't factor. There's no factors of 16 that make negative 5, so that can stay put. And that's my answer. Remember, I do have an answer key, so I would check it. And if you flip forward a couple, you'll see we got them right. I know, right? We are amazing.
You see the lightsaber one more time?
Yeah. Ooh, oh, that's not it. Hold up. Ooh, look, evil lightsaber. Dark side.
Lovely.
The red one.
What app is that?
This app
Yeah.
is... All right. So after you get these couple down as examples, be ready to finish this thing up on your own. You can holler if you have any questions.